Hello everyone, welcome to this presentation by Jinko Electronics. We are going to be talking about electronics simulation with Multisim. As we know, if you are in the education industry of electronics, you must have come across this software one way or the other. It has been over existence for like 25 years now. They have helped to, bring an intuitive understanding of electronics using this product. The product has intuitive schematic capture, accurate simulation and analysis. It's so powerful that if you are doing electronics without this simulation, your understanding will be limited, because under simulation we have more explorations to do that will make us to further understand the circuit in another dimension. So today we are going to be checking out Multisim and how it can be of benefit for those studying electronics and designers of circuits. Alright, we are in the interface now of Multisim. Circuit design suite. It has a lot of tools, from schematic capture to simulation and also PCB design. So the top, we can see where my cursor is. That's the title bar. It said design 1 Multisim. So we have not saved it with any name, so it comes like that. Then the next one is the menu bar. It has a lot of menus, like the file. This is where you can save your file. You can open files, edit, just like normal program. Viewing, to place your components, MCU, that's a microcontroller unit, simulation, transfer, tools, reports, options, windows, and help. So we have also menu bars, like this now is for, this is the main bar. If you want to check them, you can right click and see them. If I say main, it's gone. So that's the main bar. While this one is the simulation bar, you can see it has gone. This one is the place probe. You can see. So let me start from my top left. This one is the standard bar. You can see it. It's almost the same with the file. It has open, sample, and so on. Then by my right is the instrument toolbar. We have multimeter like this now. If we click, we'll see multimeter. You can see it has all the ranges. We have function generator. We have this watt meter. We have oscilloscope. This is a virtual oscilloscope. You can see. And so on. But we also have real life equipment, the virtual version, like this now. When you can see, this is the real life equipment that you can on. You can see, you can change the values, just like the real instruments. We also have real oscilloscope from Tektronix. You can see now when you on it, you can see how it looks like. You can change all this value and so on. So this is how the multisim is. So for instance, now I can open a sample file and let me check, let me do analysis. I pick a buck converter now. This is for power electronics. You can see this is the power switch transistor. This is the square wave that drives the gate of the MOSFET, and this is the flyback diode. This is the inductor for filter. This inductor makes sure that the current is stable due to variations of load. Then we have the capacitor. The capacitor has what they call ESR. That's a kind of resistance that the capacitor has. Then we have the load. This is the load. This is the resistance of the load. So if we click on run this button here, we can run the simulation and click, and we can see the waveform. You can adjust it the way you like. You can see this is a steady state now. So that's how it works. So any kind of circuit you can build. Okay, let me close this one now. Let me open to the components. I don't think the component here. The components toolbar. You can see now. When we place, you can see it has everything you think of. This is the master database. We have sources, power sources, signal sources, current sources, control sources, and so on. And you can see, you can select them, any one you want. You can also see the symbol by your top right. Basic. We have virtual components. We have rated components. These rated components are very good for doing troubleshooting exercises, because you can design a circuit with a certain power rating and exceed that rating. When you exceed that rating, it will blow up. I'm going to show you an example in a later video. Now then, we have diodes, different kinds of diodes: Zener diode, LEDs, Stocky diodes, diac, triac, variac, and so on. Pin diode, then transistors, different type. You can see all of them. We have both real part numbers and virtual numbers. Those virtual numbers, you can customize them. You can change the variables that determine them. Analog, op amps, comparators, audio amplifier, current sense amplifier. You can see them. MCU. The problem with this MCU is only this version doesn't have Arduino inside. It's only PIC microcontroller, 16F84. That's the most common one at those time. We have advanced peripherals, LEDs. You can see them. In fact, it's a complete suite of components. Okay, so I think for now we have seen how it's done. So I think in the next video we'll do some experiments. Thank you.